I would like to go over an intuitive proof of two theorems that you might have encountered in high school mathematics regarding polynomials. The first one is the polynomial remainder theorem, which states that the remainder are an element of a real number of p of x, a polynomial of degree at least 1, divided by the monic binomial x minus a is p of a. And here's the proof. If we write p of x is equal to q of x times x minus a plus r, where q of x is another polynomial with degree 1 less than p of x, then we have it where if we plug in a into x, so p of a is equal to q of a times x, well, a minus a plus r, which is the remainder we're looking for, and this is equal to, well, a minus a is equal to 0. 0 times q of a is still equal to 0, and 0 plus r is equal to r. So we have it where p of a is equal to r, the remainder of p of x over x minus a. And this is very helpful because it is used in the proof of the polynomial factor theorem, which states that x minus a is a factor of p of x if and only if, so this is biconditional right here, it's two directions, p of a is equal to 0. So what we have to do to prove this theorem is, because this is an if and only if, we need to prove both directions. So first, we prove the forward direction. X minus a is a factor of p of x, implies p of a is equal to 0. So to do this, we'll simply write p of x. So we know that x minus a is a factor of p of x already. So we have it where, okay, so x minus a is a factor of p of x. What does this imply? This implies that p of x is equal to q of x times x minus a, with no remainder, because x minus a is a factor of p of x. Okay, so this implies that if you substitute a for x, p of a is equal to q of a times a minus a. Well, a minus a is 0, and we just get p of a is equal to 0. Okay, so that proves the forward direction. What about the backward direction? The backward direction starts off with if p of a is equal to 0, then we conclude that x minus a is a factor of p of x. So if we start off with p of a is equal to 0, then this implies that by the polynomial remainder theorem, which was proven earlier, p of x is equal to q of x times x minus a plus r, and q of x times x minus a plus r, well, what is r? r is equal to p of a. So this was proven earlier. R is equal to p of a by the polynomial remainder theorem. So we replace r with p of a. But our premise states that p of a is equal to 0. So we have q of x times x minus a, and this p of a is equal to 0. So we're just left with q of x times x minus a. Oh, look, the remainder is 0, right? So this implies that x minus a is a factor of p of x. Okay, so that completes the proof for both of these theorems.